Today we're going to begin our adventure with looking at slopes. Your objective that you are writing down today is that I will be able to find the slope, which can also be called the average rate of change, and we'll be able to find the y-intercept from an equation. So our two goals is to be able to find the slope and the y-intercepts from equations. Once you have your title and objective down, go ahead and move to the next slide. In order to find the slope and the y-intercept, the very first thing you need to do is make sure that the equation is in slope-intercept form. Another way to say this is it's in y equals form. So we have y equals mx plus b. M is our slope, and you usually see it written as a fraction. And b is the y-intercept. That's why it's called slope-intercept form, because we're talking about the slope and the y-intercept. So take a moment to get these little notes down that we are looking at m, the slope, and b, the y-intercept. So here's our first example that I would like you to write down. You write down the equation y equals 3/4 x minus 2. The slope, or the m, is the coefficient or the number attached to the x. So the slope here is rise 3, run 4. So you're simply going to write the slope as 3/4. Notice I did not write the x. The slope is simply the number attached to the x. Now the y-intercept is the number on the end. Please make sure that you take the sign in front of it. That is a -2, which is the same as a -2. So this is a positive slope, which if you visualize is a rising line, and it goes through the y-line. It has a y-intercept at -2. Let's look at our next example. We have y equals x plus 7. Well, if I look here in front of the x, there is no number. One thing that we need to catch on to this year is that if we have a variable with no coefficient, no number in front, it is understood to be a 1 there. So the slope is actually 1. If we wanted to say it as a fraction, we could say it's 1/1, or we could just say 1. Both answers would be acceptable. The y-intercept is the b, the number on the end, the plus 7. We don't need to write the plus. It's understood to be positive, so we just write 7. When you're ready, write down your next example. Now, sometimes, before I get to the next example, sometimes the equation is in standard form instead of slope-intercept form. Standard form means the x term plus the y term are on the left side of the equation, and the c, the constant, the plain old number, is on the right. An example of what this might look like is the equation 2x plus 3y equals 6. That is an equation where the x and y term are both on the left, the constant number is on the right. In order to be able to find the slope and the y-intercept, we must change standard form to y equals mx plus b form. So our first step is to add or subtract the entire x term to the other side. So if I were to do that step here, I need to take the opposite of a positive 2x, which is a negative 2x. The reason I do the opposite is 2 minus 2 is 0. That's how I make it go away. If I were to put a positive 2x here, 2 and 2 would be 4, and then it didn't go away. But there is a rule that says whatever you do to one side, you must do to the other. Now on the left, we still have our 3y, so I'm going to write that down here. And then on the right, we have 6 and a minus 2x. They are not like each other. If you remember from Unit 1, they do not both have x's on them. We do want to have it in y equals mx plus b form, meaning the x term comes before the constant on the end. So I'm going to write that negative 2x first, and then the positive or plus 6 behind it. The next thing we need to do is divide everything by the b. The b is the number attached to the y. So if I sit here and take the coefficient 3 and I divide it, now I need to divide every term by 3. Divide by 3, divide by 3, divide by 3. The reason we divide by the exact number on the y is because 3 divided by itself is 1, so there's my 1y equals. Now I have the fraction negative 2 over 3 x plus, we can reduce. 6 divided by 3 is 2, and it's a positive 2 because both numbers were positive. Now this equation, y equals negative 2/3 x plus 2, is in slope-intercept form. We could easily now say the slope, the m, is the fraction negative 2/3, and the b, the y-intercept, is the constant on the end, positive 2. So take a moment to make sure you get those steps down, because our next example, we're going to be practicing how to change standard form into slope-intercept form. Move to the next slide when you are ready. So here's our next example. You will see it is not in y equals form, so it is not ready for us to identify the m and the b. Our first step is to move the x term to the other side. It is a positive 5x, so I'm going to do the opposite, a minus 5x. And whatever I do to one side, I must do to the other. Over here, 5 minus 5 is 0. It is gone. But I still have my negative 2y on the left side. Don't lose this sign in front of the 2. It's negative 2y. On the right side, these are not like terms. They do not both have x's on them. I'm going to take the x term and write it first. That is a negative or minus 5x, and that is a minus 10. My last step is going to be to divide by the number on the y. It must be the exact same coefficient, negative 2, so I divide by negative 2. The reason I do that is a negative divided by a negative is a positive, and 2 divided by 2 is 1, so there's my 1y. But remember, if I divide by negative 2 here, I must divide each separate term by negative 2. Now let's reduce our fractions. A negative divided by a negative is a positive. 5 over 2 cannot be simplified. We do not want to change it to a mixed number because we want to rise 5, run 2 when we graph later. A negative 10 divided by a negative 2, a negative divided by a negative is a positive, and 10 divided by 2 is 5. Now, much easier to identify the m and the b. The slope is the number attached to the x. That's rise 5, run 2. The b, the y-intercept, right here on the end, positive 5. The reason we want these two pieces of information is because coming up in our next section, it's going to be super easy to graph these. We will go to positive 5 on the y-line, 1, 2, 3, 4, 5, and place a point. And then we will rise 5, run 2, 1, 2, 3, 4, 5, run 2. I realize I'm at an angle, but that's okay. And then we will have our graph. So knowing where the y-intercept is and how we're rising and running, we can graph super easy. But if the equation starts out in standard form, we need to be able to adjust that. So take a moment, look at this next one, see if you can rewrite it in y equals form, and then identify the slope and the y-intercept. Unpause the video when you're ready. So how did you do? Did you see that you needed to subtract the 2x on the left and the right? And once you did that, that leaves you with a positive 4y on the left. Put the negative 2x first and then the plus 16 on the right. Divide by the exact number, the coefficient attached to the y, which is a 4. Divide not once, not twice, but 3 times. Then we reduce our fractions. 2 over 4, they're both even numbers. We can reduce them to 1 over 2. The signs are different, so it is still a negative fraction. And then 16 divided by 4 is 4. The slope is a negative 1/2. The y-intercept is a positive 4. So if you are imagining negative slope, which means a falling line, if I were to visualize this, that is positive 4 on the y-line. And then a negative slope means down 1 to the right 2, down 1 to the right 2. we can see that this will become a falling line once we start graphing. Knowing how to identify the M and the B will make graphing in the next section much easier for us. Another way to look at slope in a real-life situation is to look at slope as an average rate of change. So your last title for the notes is going to be average rate of change is another way to say slope. The first thing we need to remember is to decide which variable is the independent variable and which is the dependent variable. We did this a little bit in Unit 1. Remember, the dependent variable, that value depends on whatever this variable does. The next thing we need to keep in mind is that we need to write ordered pairs for the given information. Once we decide which one's independent, that's our x value, and our dependent is our y value. Once we know which variable is which, we can write an order pair to represent a real-life situation in the form x comma y. Once we have the coordinates of two different points, we can now find the slopes for those two ordered pairs. We have the formula that we learned just yesterday, that slope is y minus y over x minus x. Once we have our answers, our slope, it is very important that we write the answer using the correct labels. And we will practice that in our upcoming examples. Once you have these notes down, you're going to move on to the next slide where we're going to practice real-life situations finding the slope, which is the average rate of change. Looking at our first example here, we have on the 5th week of school, you have $25 in savings. On the 9th week of school, you have $53. First thing we want to do is identify independent versus dependent. Remind yourself that independent is the x, dependent is the y. Well, the two things we're talking about is the weeks or the time and the money. So now you want to ask yourself which value depends on the other. Does the time depend on the amount of money we have, or does the amount of money we have depend on how much time has gone by? The amount of money we have depends on the time that has gone by. So that means our independent variable is time. Time goes on no matter what, but the amount of money we have depends on how much money or how much time has gone by. So let's take a moment and write those two ordered pairs. We said the x value will be time and the y value will be the money. Well, the first example says on the 5th week of school, we have $25. So that's on the 5th week, we have $25. Our second point says on the 9th week of school, we have 53. So when 9 weeks have gone by, our value we have in savings is $53. We have just come up with the coordinates of two different points. And you will find from now till the end of this class, anytime you are given 2 points, the first thing you're going to be asked to find is the slope or the average rate of change. They are both meaning the same thing. So if you remember from yesterday, slope can be found by subtracting your 2 y values on top and subtracting your 2 x values in the denominator. So in case you need a little reminder, you might want to label your points. These are the x and y coordinates from the first point, and these are the x and the y coordinates from the second point. So when I go to find my slope, the y from the second minus the y from the first. 53 minus 25. That's going to be all over. We're going to subtract the 2 x's. 9 minus 5. So on top, 53 minus 25 is 28. On the bottom, 9 minus 5 is 4. Now that can be simplified to a whole number, so we don't need to leave that one as a fraction. 4 does go into 28 7 times because 4 times 7 is 28. So that has a positive slope of 7. Question is, what does that mean? What did we subtract on top? The y's was our money. So this is $7 per, so on the bottom, we subtracted the time or the weeks. So that means we are putting $7 per week into savings. Take a moment and make sure you have that down and labeled correctly, and move on to our final example for the notes. So for this final example in your notes, you're writing down the example that a cashier earns $15 after 2 hours and $30 after 4 hours. We need to identify which one is the independent X value and which one is the dependent Y values. When I think about these, the dependent, the money, depends on the amount of time or hours we have worked. So the hours are independent, time goes on no matter what, but the money does depend on something. The money you get on your paycheck depends on the time you've worked. From this, let's create our two ordered pairs. The first one says we earn $15 after 2 hours. We said X is the hours, so the way we're going to write that is after 2 hours, we have earned $15. Our second point says after 4 hours, we have earned $30. So the coordinates of the 2 points that we're using are 2:15 and 4:30. If it helps you to take a moment and remind yourself that this is the X and the Y from point 1, and this is the X and the Y from point 2. So now we're going to find our average rate of change, which is our slope. So M, slope, is equal to 30 minus 15, and then on the bottom we're going to subtract our X's, 4 minus 2. On top, 30 minus 15 is 15. On the bottom, 4 minus 2 is 2. If we change that, since we're talking about money, 15 divided by 2, or 15 divided by half, is $7.50. Make sure you label that. That's $7.50 what? $7.50 per. How often are we earning that? What is our unit rate of change? We're earning that per every 1 hour. So take a moment, make sure that you have written down the problem, identified the independent and dependent variables, created the two ordered pairs, and found the average rate of change. So if you were to take a moment and go back to the original objective for today, were you able to do it? Were you able to find the slope, which is the average rate of change, and the y-intercept from an equation? We did that in the beginning, and we found the average rate of change from real-life situations. If you are still unsure of these two goals, please take a moment to re-watch the video and make sure you catch up on things and bring your questions to class tomorrow.